Friday, sorry. I'm getting my days mixed up. So I wanted to do just some of the problems on the interval of convergence test. Please don't watch this video until you've watched or attended the lecture for Friday, because I'm not going to cover the concept of these problems. I'm just going to be doing them straight up. So I'm assuming that you've already listened to the lecture or already covered the concept. So I'm not going to be explaining the concept again. I'm just going to be doing the problem. So I'm going to be doing a couple problems that I think might help you, because I know you guys have your AP test coming up that you got to focus on. So try not to do your best. Try not to just write the answer, right? I know that's really hard to do, but really try to understand it. Maybe do it first. I'm going to ask you to pause the video, especially for my students that I'm substituting for. At the right moment, please stop it when I tell you to and try to solve it on your own before I give you the answer. Okay, so ratio test is what we're using for all of these problems, because that's the most common test of what these bounds are. So as you can see, we have these three cases right here. If you can see my black marker here. Okay, so I'm assuming that everybody knows what the ratio test is, okay? And that's going to give us our bounds, our intervals, right? So those are our three cases, okay? So every single problem, basically what you do is the ratio test, right? So this is your ratio test right here. So let me write this down here. Ratio test. And we should all be familiar with that because it's the n plus 1 over a sub n plus 1 over a sub n. And for this one, I'm just going to cover what I did for the n plus 1. So as you can see from the original problem, I added 1 here, I added 1 here, and then the bottom is just the exact same equation from here. Okay, and then obviously I do the reciprocal, and this is what it gives me. This becomes that, okay? So I'm going to cross this out now because it's going to confuse us. Okay, so now we have x minus 1 to the n plus 1 over 4n plus 1, and then we have multiplied by 4 to the n over x minus 1 to the n, okay? Now, this is sort of the tricky part because we have to simplify this as much as we can. So, a simplifying rule here, okay? So we have x minus 1 to the n plus 1, and we have x minus 1 to the n. And for that, it's going to simplify as x minus 1. So I'm going to write that right here. That becomes x minus 1. Okay? And I'm just going to explain it for this problem how I got that, because x minus 1 times n. If I want this to become x minus 1 to the n plus 1, I have to multiply this by x minus 1, because this has a 1 exponent, right? And when you multiply exponents, you add them, right? So this is n plus 1, right? N plus 1. So this is the part that's missing, which is why when you factor it, you get x minus 1 here. And that's the same with any other case, okay? And x minus 1 is actually going to be in my numerator because it's the n plus 1 is right here. Right? There's one more than this one right here. Hopefully that makes sense. So now for these two, let me do it in a different color. We have 4 to the n plus 1, and we have 4 to the n. And that can also be factorable. That one would just be 4. Again, this is the only time I'm going to be explaining this. So if I have, then 4 to the n was my other one. So something times 4 to the n is going to give me 4 to the n plus 1. That should be an exponent, sorry. So something multiplied by 4 to the n gives me 4 to the n plus 1. That's 4 to the first power, but we don't really write first power, right? And then whenever I multiply exponents, I add well, whenever I multiply exponents, I add them. Yes, so this is 4 to the n plus 1. So the missing value is 4, which is why at the bottom here is 4, because it's in the denominator because there's a 1 here. There's an extra 1 than this top right here. So hopefully that makes sense. And now we can analyze this, right? And we have to use these 3 cases up here, okay? Another telltale sign that I will tell you is you have to get your ends out. So your ends are going to represent something. If your ends don't cancel out, so your ends either have to cancel, and you want to be dealing with x's when you do the boundaries, okay? So x minus 1 over 4, out of these 3 cases, I want you to pause the video and try to think which case does that fit. Would that be the first case, second case, or the third case? If you resume the video, it would be the first case, where it is less than 1. Because whatever number I plug in for x as it gets increasingly large, so if I plug in 1, that would be, no, 1 would be 0. So if I plug in 2, that would be 1 over 4. If I plug in 3, that would be 2 over 4. If I plug in 4, that would be 3 over 4. As we can see, it's approaching 1. Hopefully that makes sense. So that's why we are using the first case right here. Okay, so the ratio test states that it's -1 to 1. And this, I want to get x by itself, so I would be multiplying this by 4. Let me try to use a different color. Multiplying it by 4, this would be -4 less than x minus 1 less than 4. Multiplying it both sides by 4. And then we add 1. So this would give us -3 less than x less than 5. Now, we're not done yet because the question is asking us for the interval of convergence. So whenever it asks you that, you have to test the endpoints. Okay, so simply with these x values, oh, I don't know what happened there. With these x values, you're going to be plugging it into the original equation. I apologize, it is kind of messy here. So the original equation, I'm going to draw a box here. This is the test. So the original equation was x minus 1 to the n over 4 to the n. And one of my x values is -3. And that would simplify to -4 to the n over 4 to the n. And that would also simplify to just -1 to the n. So the left bound would be sigma n to the 0, infinity, -1 to the n. And if we use the nth term test, which I'm assuming you did, this does not approach 0. Which means that this diverges. So we know that the left bound diverges. Okay. Five. Okay, so when I plug in 5, this simplifies to 4 to the n over 4 to the n. And this goes to infinity, because if we use the nth term test, this is going to give us 1, right? So 4 to the n over 4 to the n is just 1. And the limit of 1 is not 0, which means this also diverges. Remember, in order for a series to converge, it has to approach 0, equal to 0. Okay, so hopefully that makes sense. Simplifying part, these two bases have x minus 2. This one has the plus 1. So I know that when I simplify, it's going to be in the numerator, and that's going to be x minus 2 when I simplify. Now I have this 2n plus 1, 2 to the n plus 1, sorry, and then I have this 2 to the n. So this plus 1 is at the bottom. There's one extra one on the denominator. And now, the only part that's left is this n and n plus 1, right? So n over n plus 1. Okay. Very good. Again, don't forget the absolute value. Sorry about that. Okay, so this might get tricky because you might be wondering, why is there x's and why is there n's? Remember, when we use the ratio test, the n's tell us something. There's 3 cases for the n's. The n's have to go away in order for these problems to work. So the n's are going to give us the bounds. So n over n plus 1, we know that that's headed to 1. Okay, so if we keep plugging in, for example, I'm going to erase this 1 plus 1, this equals 1/2. And if we plug in 2, that's going to be 2 over 2 plus 1, which is 2 over 3, which is bigger than 1/2. And then when we plug in, let's say 4, that would be 4 over 5. That's 80%, right? 0.80. As you can see, it's getting closer and closer to 1 as the number gets bigger. So this n to the n plus 1 is our first case. Let me erase this. It's our first case because it's approaching 1. So that means we're gonna get rid of this. And we're left with x minus 2 over 2. And this is going to be less than 1 and greater than negative 1 because it's the first case. Hopefully that makes sense. And we know what to do here. We just get x by itself. So this gives us negative 2. So add 2, add 2, add 2. This gives us 0 is less than x and x is greater than 0, less than 4. And take the original equation, which is this. Yes, it is kind of disgusting, but you're only plugging it in for x, right? So it shouldn't be that, it shouldn't be too bad. This part right here, that would give me negative 2 to the n. However, I can make this easier to tell. There's a specific series that we've learned that we can make it look like to find it easier to whether it will converge or diverge. So this, we can take out the negative here. Okay, let me go back here. So this negative, if we take that out, this is going to equal negative 1 to the n to the 2n. Right? That's just another way of writing this. It's the same thing. The reason why I did negative 1 to the n is because it's a harmonic series, right? That's something that will make our life easier at the end to tell whether it will converge or diverge. I'm just making my life easier. Okay? So when I simplify that, it would be negative 1 to the n plus 1, and then negative 1 to the n 2n, and then n to the nth power. Now, if we were to simplify this further, we can combine these two. That's another reason why we wanted to do this part, so we can combine them. And then these two cancel out, right? This 2 to the n and this 2 to the n. So the only thing that's left at the bottom is n. So we're going to have, if we were to combine these two, it would be negative 1, 2 n plus 1 over n. Let me draw parentheses here. Negative 1 to the 2n plus 1 over n. And that still isn't really clear whether it diverges or converges yet. So if we were to simplify this even further, so this would be negative 1 to the 2n, and then we would have negative 1, and then this is over n. Okay, I just split these two up for this one right here. Okay, very good. And then we're just left with negative 1 to the negative 1 over n. And that is just a negative harmonic series, right? That should be something we're familiar with. And we know that negative harmonic series diverges. Okay, and since I'm running out of room, I want you to try the other one when you plug in 4. Again, do the n plus 1. This is what I got when I simplified for the n plus 1. So this part right here with this factorial, I can simplify that, right? If I distribute, that becomes 2n, and then 2 plus 2. I mean, 2 times 1, which is 2, right? So then I have the limit, n approaches infinity. I have 2n plus 2, 2n plus 1, and then 2n factorial. Because it keeps going down, right? That's what factorials do. So when I distribute the 2, it gives me 2n plus 2, and then it keeps going down as a factorial, all the way to 2n. Okay, and then at the bottom here, I have 2n factorial. I want the n's to cancel out, essentially, so that's why I went all the way to 2n. And then we know with this part, the x over 3, n plus 1, and x over 3 to the n, if we simplify that, that's going to be x over 3. And this is absolute value. Never forget absolute value. That's very important. Now, when we look at this one, though, we know the previous two examples we had, the first one, where it was less than 1. But this one, I want you to pause the video and try to think, is this going to be the first case, or is it going to be some other case? So try to think about it. This numerator part is bigger than the bottom, right? This numerator, so as we can see, this numerator part with all these factorials is bigger than the denominator. So we know that this numerator is going to infinity. And we know when it approaches infinity, it then converges only to the center. Now, in this case, the center is going to be 0. Because it doesn't specify a specific center, right? It doesn't give us like a x minus c. It only gives us the general p series, which is to the nth power, right? So we know that this converges at x equals 0, right? Because of this third case. So hopefully that made sense. I wanted to cover that one because that can get a little tricky, right? We clearly see that this numerator is way bigger than this denominator. So it's easy to tell that it's going to infinity, which means it converges on the center, which means it is at 0 because it is the general form of the power series. Minus 0 to infinity, a sub n, x minus 5 to the n. So c is 5. That's your center. This is what it's telling us. It converges at x equals 8, and it diverges at x equals 10. Okay, so right off the rip, I know that my center is at 5. So I'm just going to I'm going to draw a dot here. And this is my center. Okay, that's what the information gave us. Now, it says it converges at x equals 8. So I'm going to draw it in red here. Okay, red means it converges. I'm just going to be drawing this right here. So we know that from the center to 8, it converges, right? This is converge. And that is, it went 3 units. So that means on the other 3 sides, the other 3, which is this way, so 1, 2, 3. So at 2, right here, this part also converges because a radius goes both ways. So this is 3, this is 3. Now, it says it diverges at x equals 10, right? So I'm going to be drawing that in yellow. So x equals 10. So yellow diverges. So if it starts at the center and if it goes all the way to 10, that is a 5-point difference, right? As we can see. So that means the other 5, which is at 0. Sorry, I didn't write 0 here. Right here. This is also 5 on the left because the radius goes both ways, right? Very good. Now, from all that information, I want you to try and figure out the choices by itself. So the first choice says the series converges at 2, x equals 2. The second choice, it says it converges. I spelled that wrong. Converges at x equals 3. And then number 3, it diverges at x equals 0. Okay, now technically all these choices could work, but in the multiple choice section, there can only be 2 answers or just 1 only. Okay, you can't choose all 3 right here. Number 2, because it's within the boundary. Okay, so 3 is within the boundary of where it converges. Now, obviously, 2 is within the boundary too, but I think it has to be like within the boundary, not at the end, is what I'm assuming. She wrote maybe for these answers, so they could work, but I mean, you can't choose all 3, right? Because the answer choices only give you, if it's either 1 only, 2 only, 1 and 2 only, or 2 and 3 only, right? So I think the answer is just B. It's just 2, because that's the strongest answer. Okay, so hopefully that made sense. You know that that's the center, right? So I'm just going to label this as the center. Satisfy a sub 0 equals 6, and a sub n equals 2n plus 1, 3n plus 1. A sub n minus 1 for all n greater than equal to 1. What is the radius of convergence? Okay, so this one can be a little tricky. With this given condition, we need to do the ratio test for this as well, because it's included in this radius of convergence, right? It's a given boundary, so we have to incorporate that, right? So if we have limit of n to infinity, a sub n plus 1 over a sub n, and then a sub n, x minus 3 to the n, right? That's what's given in our original problem. Okay, so if I were to just do the ratio test, right, that would just be a sub n plus 1, and then x minus 3 n plus 1, right? So that's the ratio test for that part, right? And now we know that a sub n is given to us, which is this part right here, right? So 2n plus 1 over 3n plus 1. So now a sub n and then 2n plus 1 over 3n plus 1, a sub n minus 1. This equals a sub n. So that's important, right? Okay, now if I were to do the ratio test for this, okay, notice how this has a sub n minus 1. Okay, I want to get an plus 1. That's my goal. So what can I do to this to make this a sub n plus 1? Please try to pause the video and try to think about that. Radius of convergence, right? It's a given boundary, so we have to incorporate that, right? So if we have limit of n to infinity, a sub n plus 1 over a sub n, and then a sub n x minus 3 to the n, right? That's what's given in our original problem. Okay, so if I were to just do the ratio test, right, that would just be a sub n plus 1 and then x minus 3 n plus 1, right? So that's the ratio test for that part, right? And now we know that a sub n is given to us, which is this part right here, right? So 2n plus 1 over 3n plus 1. Gosh darn it, I don't think I can go down more. Okay. Well, that's not good. Okay, I'll do it over here. So now a sub n and then 2n plus 1 over 3n plus 1, a sub n minus 1. This is this equals a sub n. So that's important, right? Okay. Now, if I were to do the ratio test for this, okay, notice how this has a sub n minus 1. Okay? I want to get an plus 1. That's my goal. So what can I do to this to make this a sub n plus 1? Please try to pause the video and try to think about that. Okay? I would have to add 1, right? So if I add 1 here, this cancels. And if I add 1 here, this is a sub n plus 1. And if I do a sub n plus 1, that means I need to do a sub n plus 1 in this portion as well. So plug in plus 1 for the n's, right? So what does that give us? That gives us 2n plus 2 plus 1. So that's 2n plus 3. And then this one at the bottom, 3n. And then this is plus 3, plus 1 more is 4. So this is 3n plus 4. And this gives us a sub n plus 1. I forgot the a sub n. Sorry about that. And I want it to look like the ratio test, right? So this is just a sub n plus 1. But I want this to have over a sub n, right? So I would be dividing this by a sub n on both sides because I want it to look like the ratio test. And that is our answer for that. So that's what we have to use for that given problem. Okay? So make sure both categories are ratio tests. Make sure they're both plus 1. Okay, so now of n to infinity, okay, we got 2n plus 3 over 3n plus 4. And then we got the boundary, the center, right? So that's going to be 3x minus 3 n plus 1 over x minus 3 to the n. Make sure that's absolute value. Don't forget that. This gives us x minus 3. And remember, when we take the limit, we only care about the variables, right? So these constants go away. So this would be 2 over 3. And the n's cancel out, right? So limit n approaches infinity, 2 over 3. And then this is less than 1. Okay? So now you add 3, right? To both sides. Oh, this is negative 1, 2 over 3, x minus 3 less than 1. Divide this by 2 over 3, which means we'd be multiplying by 3 over 2, so multiply by 3 over 2. So that would be negative 3 over 2 x minus 3. And then this would also be multiplied by 3 over 2, so it's just 3 over 2. And then add 3. Add 3. Add 3. I'm just going to plug that in a calculator real quick. That would be 3 over 2 greater than x. X is greater than 3 over 2, less than 9 over 2. So then if you simplify that as a decimal, that'll be 1.5 less than x, less than 4.5.